Coming to the next theorem, Thevenin's theorem. Straight away, starting with the problem. Question is to find the Thevenin's equivalent circuit at terminals A and B. The diagram given is 100 angle 50 volts A B minus J6 ohms, 4 ohms, J12 ohms, 8 ohms, and these 2 points given are D, F, C, E. We need to find the Thevenin's equivalent between these two terminals. So solution, first I'll find the Thevenin's equivalent voltage. I'll redraw this circuit as can say D is only one point. From that you have one capacitor and you have one resistor, 4 ohms minus J6 ohms. Then these are the 2 points A, B. Here you have 8 ohms, here you have J12 ohms. This is point D, this is point F, this is point C, and this is point E. Both are the same potentials, Now VTH is between these 2 points. So for finding VTH, we need to find the current in both the branches. Say I am assuming this as I1, this as I2. So we need to find both the currents in this case. Now I1 I can find as the total voltage is same across all the branches. So I can say total voltage upon total resistance can give me the value of the current I1. So 100 at an angle 50 upon 8 minus J6 will give me the value of I1, and for I2 it will be 100 at an angle 50 divided by 4 plus J12. So I1 comes to 10 at an angle 86.66 amperes and I2 comes to 7.9 at an angle minus 21.56. So I've got I1 and I2. Now the equation for VTH will be, I am starting from this point, it will be VTH minus J6 into I1, because it would have been plus J6 into I1, but since the sign is negative it is coming minus J6 because we are going in the direction opposite to I1. If there would have been a resistance, it would have been plus I1 into the value of resistance, but the value of resistance is negative, hence you are getting negative sign here. Minus 4 I2 equals to 0. So if I substitute I1 and I2 in this, I can find the value of VTH, which is J6 times I1 plus 4 times I2. So this will come to 60 at an angle, the total value of VTH will be 31.57 angle minus 165.10 degree volts. So this is the value of VTH after substituting I1 and I2 in this equation. If you want to simplify, just put this value of I1 here, this value of I2 here, then you will get few steps and finally you will get the answer as this. Otherwise I'll show that also. So it is 60 angle 176.66 plus 31.6 angle minus 21.56. So when you add these two, you will get to this value. Now to find the value of RTH, what we do, we since there is no dependent source over here, what we can do is we can short circuit the voltage source and open circuit the current source. So the normal way we can find the value of RTH. So D and F will be the same point because these two will be shorted. So what I'll do, I'll take F and D to be the same point and A and B to be the different points. Say this is A, this is B. Here you have F and D, same line. You have a same line for F and D. Now you can see uh, E and F are same. E and A are same point. So I can say E comma A. B and C are same point. So I can say B and C. Between D and E you have minus J6. So I'll draw. This is my line for E and A. So this is minus J6. Again between C and D you have 4. So between C and D I'll draw 4 ohms. Then C and F you have J12. So C and F you have inductor which is J12. Now this 8 ohm is left, it is between E and F. So this will come here 8 ohms. So this is how I have drawn the equivalent circuit. Now the equivalent of the parallel combination of these two, I'll call it as Z1, and parallel combination of this I'll call it as Z2. So I can say my Z1 will be minus J6 in parallel with 8 and my Z2 will be 4 in parallel with J12. So after simplification, Z1 will be 2.88 minus J 3.84 ohms and Z2 will be 3.6 plus J 1.2 ohms. So total ZTH will be Z1 plus Z2, since both are in series. So you will get it as 6.48 minus J 2.64 ohms. So we have found the value of VTH and ZTH. Now to draw the equivalents, Thevenin's equivalent circuit, we need to draw. So it will be having your VTH and your ZTH, and it will be between terminals A and B. So these are the two terminals. This is your ZTH and this will be your VTH. VTH you have found it to be 31.57 angle minus 165.10, 6.48 minus J 2.64 ohms, or again you can convert it to the rectangular form, 6.48. You can do it in the 6.48 minus 2.64 I, you can straight away convert it to the polar form, as you will get it as 6.99 at an angle minus 22.16 degree ampere. There is a shortcut you can straight away use in this calculator. If you have a rectangular form, say 6.48 minus 2.64 I, then in this case you can do it shift 2 3 and equal to. So this straight away will give me a conversion from rectangular form to polar form. So I have got the value of VTH and ZTH. One problem you can try on your own. Say question number 2. Find Thevenin's equivalent circuit between terminals A and B. The diagram given is plus minus 75 angle 20, then 6 ohms, J2 ohms, minus J4 ohms. Here you have A, here you have B, 10 ohms. The answers what you should get for this are VTH, you should get it as 47.42 angle minus 51.57 degrees volt, and RTH you should get it as, or you can say ZTH, you should get it as 12.4 minus J3.2 ohms. So these are the values of VTH and ZTH what you should get for this problem. Thank you for watching.